Alright, so we'll be talking about Leibniz theory part 2, where we'll be now finding the nth derivative. Given a function, now we'll be finding what? The nth derivative. So in short, we'll be trying to trace a certain pattern on how that derivative will be changing. Alright, so shall we start? Suppose you are given the function to say y is equal to, let's say you are told y is equal to what? 1 over what? X. Okay, so what we do is you can write this one in index 4 so that you can differentiate properly, so that will be -1. So differentiating y now will be what? You multiply that negative to be like that, then subtract that with 1, that will be giving you -2, right? Again, you can again subtract, find the second derivative by saying this will be now positive what? So what we do is we don't really write, so you write that negative which was there, you found at first, which you multiplied there. So let me do this. So there was a negative which what? Multiplied there. So negative times what? The same x to the power what? 1 to the power 2 after you differentiated, right? This is what happened. Again here, when I differentiate this one, it will be again -1. I'll maintain there. Then I'll write what? -2, then x again to the power what? -3. So this is the pattern that I'm trying to trace. Alright, so again, if I differentiate again to the third differential, this will be -1 times negative what? 2 times -3, then x to the power what? -4, like that. Have you seen? So in short, as this one I'm keeping on differentiating, there is something changing. So I'll write, this is where I'm coming in to write, I'll say as I was differentiating, alright, to the power n, these are the things that we are changing, right? So this is what? 1 over x, right? When we differentiate this, we differentiated this one, some things were changing, such as this coefficient was changing like that. Okay, this one was changing, the coefficient were what? Changing. Then so I can say this is what? So allow me just to write a space there. Alright, let me start afresh. I create more space. So once you differentiate this one, so first derivative, it will be what? You multiply that negative on top there, then 1 times, alright, you write again now the same x to the power what? -2. Alright, so this is giving you what? Negative x to the power what? 2, which is what? 1 over x to the power 2. Right, so that's the first derivative. So the second derivative now will be, you maintain this one times, now you multiply times 2, that 2 you can see there, then it will be now what? X to the power what? -3. So once you, this negative and negative, it will cancel, right? So here it's negative, by the way, so it will cancel and it will give you a positive. So that will be 1 over, it's now 3x is now 3. Alright, so there's a number that you actually made there. This times that, 2 times 1, that's what? 2. So we'll keep on, like, we'll write 2 there on top there. Okay, it's positive 2. So again, I can say dy of y prime 3 prime, I'll say this is -1 continues, again -2 continues. Alright, this is now again -3 continues. You see, this is now x to the power at -4. So when you multiply this one, first thing is you multiply, the sign will be now alternating, say positive, negative, positive, negative. Alright, so this is negative. So negative, then you multiply 1 times 2 times 3 times that, that's 6, right? So 6 now to the power 4x as the highest, so it will be x to the power 4, like that. You see? So differentiating again, let's say y to the power 4 now. Alright, so this will be -1, you maintain like that, -2 you maintain like that, -3 you maintain like that, now negative what? 4 you maintain like that, then x to the power what? negative 5. So this will be, you multiply now, we had 6 times now 4, that will be positive, right? So that will be positive what? That will be positive 24. Alright, so x now is to the power what? 5. Okay, so want to trace what was changing, want to trace the pattern. If we are to give someone to say you'll be using this one once you are studying this, so I'll write n to the power n, or nth derivative. So I'll say dy dx of what? N, or just nth derivative, just like that. Alright, so I'll say nth derivative is equal to what? What was changing? First, let me start with the sign. Alright, so the sign, if what we do for such case, we write a sign like that. Alright, a negative 1 inside there. Then how was the sign changing? So I'll be putting numbers, let's say n plus 1, or just here n minus what? 1. So those are the numbers that I'll be writing to trace the pattern of the charge, negative. So what I'll do, if I write 1 there, n is equals to what? That's n is the number of derivative. So if n is equals to 1 there, 1 prime. So what we are going to do is, if I put now negative 1, open bracket, then I put 1 there, I'll get what? A negative. So meaning that it was changing by what? N. Alright, so if I get again, I come here, I say n is equals to what? 2. So I put 2 there, so I'll say negative 1, open bracket 2. So that will give me what? Positive. That's the reason why here is positive. So you trace the pattern like that. So if again I put n to the power 3, it will reverse the negative because that's a odd number. Alright, so by that we'll be able to trace the pattern. Alright, you look at those things. By the way, I'll give you the table. I will just give you something what I cracked. Like we cracked these things as Tactic Academy, so we'll give you the format. Alright, but I encourage you to keep on what. Then what about numbers? So as n was 1 there, alright, as n was 1, we go to what? 1, right? So that is just 1. But when n was 2, we got the factors what? As 2. Alright, so meaning that again as n was 3, we got what? The factor what? 3 there as the highest, right? So it was changing. So we are now taking these numbers, not the negative. We are talking about the number. So when n was 3, it gave us n3. So now if I write, mostly we use factorials. So if I write 2 factorial, this is what? 1 times what? 2, right? If I write 3 factorial, this is what? 1 times 2 times 3, right? So meaning that if I have n is equals to n factorial is equals to that, I'll have what? 3 numbers. So like for this case, here I have 1, 2, right? So meaning that n is equals to what? 2 factorial, right? Or just n factorial, because the number of n is the number of derivative, the prime. So now the prime is what? Is 2 there. So I will say when I put I want to see if the constant work, that 2. If I put n factorial, right, and n I know is 2, so 2 factorial is what? 2. So if I put here, it was giving me what? 3. So n here is equals to what? 3, right? So if I put 3 there, then meaning that I'll have what? N factorial, which is 3 factorial, and 3 factorial to give me what? 6, like that. That's the reason why it gave me 6. So for negative pattern we have traced. Now for constant we have also traced. It's giving n factorial. What about down there? Alright, as the power of x, how was it changing? Alright, so how was the power of n changing? So we could see that as n, let's say n is equals to 1 there. Alright, so n is equals to 1. So what happened there? It increased by 2, you see. So when n here was 2, alright, then the power of x is changed to what? It increased by 1. So in short, as down there, so here the factor here on top, numerator, will be changing by n factorial, right? Then down there, down there, the x now was changing by what? N, that n you have, then what? Plus 1. So it was increasing by 1. So this is the nth derivative that we have. As you differentiate, let's say 2, you just replace numbers, you'll be able to find the value of x for that function. So that's how you do nth derivative, everything like that. Okay, hope that is clear. So now for this, we trace the pattern to say when you have this, you give us, so this is the pattern now that I want to give you. So when you have that form, let's say you have 1 over x plus what? A linear down. So this one was linear as well. So a linear, let's say b, alright. So just that b here was 0. That's why you couldn't see it. So the nth derivative of such a function, please master this. The nth derivative of such a function, you write as, are you getting me? You write as the, alright. So let me write like this. So you master this pattern we have done. So questions will be coming like that. Find the nth derivative of that. So when you have the nth derivative of y, let's say is equals to 1 over, alright, let's say ax, alright, plus b, like that. So in this case b was 0 and our a was 1. So what you do is you say nth derivative of this, alright, it will be you write -1, which will be tracing the pattern to the power n, alright, then n factorial, then that constant you have there, it will be changing by what? It will be being replaced by the number of derivatives. So you say a the power n. Then down there, how will be x changing? Just like we saw. So you bring the same function, alright, plus b, then there will be n plus 1, like that. So that's how it will be changing. Please master this, I beg. So once you are solving a lot of questions, you'll be able to master this in some formulas. So you just pretend working, then at the end put the answer that you mastered from the trick. Okay, that's how you'll be solving these things. So we are done for this question, which was there on the first page, on the cover page. Alright, so as simple as that. So in the next thing now, I won't be able to show you how again to trace the pattern, but you can be trying your best to then trace the pattern. Alright, so let's go to the next thing. So that's the nth derivative. That's how you write the nth derivative of n function. So for this one, the nth derivative of that is that. Okay, so let's go. So suppose you are given, let's say, the same this one we have. Let's try this one, we see. Alright, suppose you are given the function now. So for this one, we take as if you know quotient, product, everything like that. You know everything like that. And also chain rule. You know all those rules for differentiation. Okay. So now what you do is, suppose we are given the function now, x plus 1. Alright. Then we have what? X minus 1, like that. So what you do is, you will write, this is now y. If we were to say y prime, this would be what? Would differentiate using this quotient rule, right? So using quotient rule, what you are going to do is you write the one which is down, the v, which will say let v, okay, v is equals to the down part. Alright, then the u is equals to what? X plus what? 1. Okay, then the other thing is those are the u, right? So you differentiate u, then minus, you differentiate what is down, which is the v. Alright, then you write, so this is the dy, then you write what? U, you maintain u, then you differentiate that, then you say u squared, v squared down there. So that's the chain rule. So that's the one we use for the first derivative. So of looking at this one, we'll set this one is equals to u, then this one is equals to what? V. So what we are going to do is, we'll say our v now will maintain the v, which is just x minus 1. Alright, open bracket, the du, the u man, now the du on top there, that you when differentiate x plus 1, that will just give you what? 1, right? Then minus, when you differentiate, so you maintain u, so u is what? X minus x plus 1, I mean. Then the v now, when you differentiate that one, to just give you 1 again. Alright, then over the v squared now, which is x minus 1 squared, like that. Okay. Hello. So what you are going to do is you differentiate that one, then you multiply that to give what? Just the same thing, which is x minus 1. Then here it will be negative x, then what? Negative 1, like that. Okay, so there on top, then you leave it like that, so you don't have to expand down there, so you just leave it like that. Okay, so we don't expand down there. X minus okay, so what you are going to do is you leave like that, so that will give us what? You can see 1 and what will give us negative 2, then this and this will go, so that will be negative 2 over x minus 1 open bracket 2, like that. Okay, so this is how the first derivative. So the second derivative will have a certain pattern as well. All right, we'll have this a second pattern as well. So what we do is we'll start differentiating this one. We'll be trying to differentiate, then we'll get to actually see the final answer. So this is where we start now. We'll go to the second. This is the first derivative. So now seeing the second derivative now will be, all right. Okay, so we are saying now first derivative will be what? So first derivative will be negative 2 over what? X minus 1 open bracket 2, like that. Okay, so that is the first derivative. So what about now the second derivative? So second derivative, again, what you do is you leave it like that. Okay, then that will be now negative 2 open bracket x minus 1 then to the power 2, like that. Okay, so it will be negative because it's from down. Then second now derivative will be you multiply that one, that will be now positive what? 4. All right, then x minus what? 1 open bracket, then there on top it will now negative 3. Then you differentiate also what is inside, which is just 1, so that will be what? 4. Let me just leave that one because there is no need. All right, so that's the what? Second derivative. Okay, so now the third derivative will be you multiply that one will give you what? Negative 12. Okay, so then you write x minus 1 again. Here it will be what? Negative 4. Then you differentiating what is inside, you still give me 1, so I can't multiply with 1. I'll just leave it like that. Okay, so that is it. Then from this now, this is the fourth. Let me try the fourth one. 1 2 3 4. All right, or just let's say n to the power 4. So I'll put 4 there. Okay, so if I put 4 there, I'll say differentiating that one now, it will be positive what? 48, because you multiply that negative 4 times 4, that's the positive 48. Then open bracket x, again differentiating what is inside is 1, so just leave like that, then to the power 5. So how was the pattern changing now? Then we'll conclude from there. All right, so how was the pattern changing? How was the pattern changing? Okay, so we need to trace the pattern. Okay, so we need to trace the pattern. So what we do is we'll say so we'll start now tracing the pattern to say nth derivative. As we were differentiating, these are the things that we're changing. 1, we control the behavior of the what? Negative. So the negative first derivative, when n is equals to what? 1, the negative gave. All right, so when n is equals to 2, the negative what? Went. All right, so when n was again, it brought, in short, it was becoming as we have what? Odd number. So what you are going to do, I'll write this one there. All right, to the power what? To the power n. Okay, if I put 1, I'll still have what? Negative. This is the first derivative with a negative there. So then I've traced it, I've managed to what, to find the what, the n. I know you are lost, but please, like, just master the format of each scenario. The one for quotient rule and of this type, I'll give you even the formula to use. We'll create the formula from there, and of which you should master the formula. So what you do is, then what was changing now? All right, so you see, as one was one, first derivative n is equals to what, 1 in this case, then we had what, 2, meaning that we'll put what, 2. Then, all right, by the way, I was supposed to do something here. The pattern, I can't see the pattern here, in that I wasn't increasing, so it started from -2, so there to what, x to what, -1 to the power -2, like that. Then so okay, let me just proceed by saying here it will be, now it was -2, all right, over, let's say, x -1 to the power 2. Then here it was changing us, so we had first -2, so again negative what, 2 times, by the way, then open bracket x what, minus, so I will leave it as a denominator. All right, so there on top, down there I have what, so yeah, so I have x -1 like that, the power now what, 3. So for this one I had what, I started with a -2, then now is negative what, 3. Okay, -2 again, then -3 now, then open, I mean down there we have x -1, open bracket, 4, like that. Okay, so there, here what was changing here, we started with -2, right, then times -2 again, then times negative what, 3, then times negative what, 4. Then down there what was changing is what, is the so write x -1, then to the power what, 5. So now we can see that 2 has been there in the pattern. We saw it, we found it, in short, right? So we found that 2, but what was changing is the negative, right? Because sometimes it will give us what, positive, sometimes negative, like here is positive, here is negative, here is positive. So now we have traced the change of negative as the coefficient negative. We have traced the change of this. So now what you are going to trace is, now, so there was that 2 that we found, all right, now let's trace the change in this these numbers. Okay, so this one you found it, so you write the way it is. Then now check how it was changing when n is equals to 1. All right, there was nothing which multiplied, so we, in short, it gave us what, 1. All right, so I'll write this as n factorial. All right, because if I have n is equals to 2, like this case, I have what, 2, because n2 factorial, all right, I'll say 2 factorial is equal to what, 2 times 1, which is just 2. In short, it was changing by 2 factorial. Then down here, the way it goes, this one just the same, you maintain the same thing. All right, so you say, you bring that function -1, open bracket, then n was changing plus 1. All right, so that is it about. So when you meet a function to say y, you are told to differentiate a function of linear, let's say a x plus 1, or plus, let's say b. All right, then over, okay, over, so long as it's not a quadratic, it's linear, so I'll say again, let's say cx plus what, d, like that. So the pattern will be, nth of this one will be, you just bring the same negative, the way will be, negative will be flowing like that. All right, so but this one differs with the numbers, so the negatives that are there. All right, so long as negative alternative down and up, then we'll have the same thing. So just master this pattern. For that case, when on top there is positive, down, negative, just like that with any number. These 2 and 1 can be any number. So I won't really specify the pattern because this one will keep on changing. So I want to give the pattern for this case. I'll give the pattern for the other concepts. Alright, so that's about this one. We have traced the pattern. So this is the pattern or the nth derivative of that. So you just pretend you lighting this, you pretend lighting this a bit, then you conclude this, okay, after you see what was changing. So suppose now you have let me give you the last one. Now before I even give you the last one, let me just give you this to say y is equals to root of what? 2x minus 1. So here what will be happening is that y is equals to what? Open bracket. You say now this is what? 2x minus 1 to the power what? Half. So this is how you'll be differentiating. So if you say y prime, this will be now 1 over what? 2. Okay, then open bracket 2x, alright, minus 1. Then what is half minus the 1? That is what? Negative half. Okay, so what if you have 1 to the power, to the second prime, so meaning that we have 1 over 2 times negative 1 over 2 again, open bracket 2x minus 1. Then there it will be what? Minus 1 again. What is the negative 1? Negative 1 over 2 minus 1. So you say 2 there, that will be negative 1. So that will be what? 2, which is what? Negative 3 over 2. So here it's what? Negative 3 over what? 2. Okay. So the third one, so you write 1 over 2 there times negative 1 over 2 times negative 3 over 2 open bracket 2x minus 1 open bracket, then you subtract again negative 3 over what? 2 minus 1. So that will give you what? That will give you actually negative 5. So that will be negative 5 over 2 like that. Okay, so that is it. And I can say now the last one, which is there now, which is like fourth derivative. I can say negative 1 over 2. I'm sorry, that's just 1 over 2. Then times negative 1 over 2 times negative 3 over 2 times negative 5 over what? Over 2 like that, open bracket x, that is 2x minus 1 open bracket. That will be now so you say negative 5 over 2 minus 1. So that will be what? Negative 5 minus what? 2, which is negative 7 over 2. So here it's what? Negative 7 over 2. So how was this changing? 1 will actually get the product now. So we'll get the product starting from the first differentiation. So here it will be just positive what? 1 over 2. Alright, then I'll really write down there so that I forget about everything, the negative and so on. Okay, so so this one again will complicate my thing. So what I'm going to do is I'll say I'll write it in the denominator like that. Alright, so after writing in the denominator, I'll say 2x minus 1 open bracket. That will be now, since that is negative, again I'll write 1 over that. Okay, let me just do this so that you don't get lost here. So what I'll do is I'll just write the number 1 over 2 open bracket. I'll trace the change from there. Okay, so I'll say minus 1, the same thing, I just want to have numbers now. So here it is what? Now this is negative, so it will give me negative what? 1 over 4. Then open bracket. So the change here is still negative 1 over 2. Alright, okay, so that is it. I'll see how that negative will be removed. So that will be now 2x minus 1. Okay, so that is 2x minus 1 to the power what? 3 over 2. So here it will be what? Negative, negative, there, positive, again negative. So there was negative there, again here negative, negative, negative. So that will be positive now, because this is negative and negative. So that will be positive what? 3 over what? 6, like that. Then you keep on what? 2x minus 1, open bracket, 2x, not 2x. That's not 2x, I'm tired. Okay, so now what we do on top there is the same thing there. That's 5 over what? 2, negative, like that. So then the last one is you have negative there, negative, negative, that will be negative. So on top there, 1, 2, 3, 4, that is now 16, right? 16. Then on top there I have 3 times that, that's 15. So I will write 2x minus 1, like that. Okay, then negative 7 over what? 2. So this negative we are able to see there. We'll be writing this function as, so the first one I'll write it as what? As 1 over 2. Then since they are negative, I'll write like that. Alright, so I'll be writing like what? Like that. So I can say 2x there minus 1. Okay, then now I'll be putting the numbers here, so I don't want to complicate things like that. So what I'll do instead, I'll just write like this. I'll now trace the pattern from there. So the way you trace the pattern from here now is by we need to trace the pattern here. So of that type, what will be the pattern? Okay, how was it increasing? So it was increasing by what? Negative 1. Okay, so all the numbers were negative. So what we are going to do is I'll say nth derivative is equal to, so what I'll do is I'll change first the pattern. So when n was 1, it gave me positive, alright? So I'll say n so but we normally write negative 1 there. Then I'll say when n is what? When n is 1, alright? So I'll say n minus what? 1, okay? Like that. So when n was the so I need to write like that. So when n, I want to see the change. So when n was 1, it gave me positive. So, and for sure that will be what? N to the power 0, that will be what? Positive 1. Then if I have n negative 1 power there to the power what? I want to close, because the negative was coming out, leaving out, come like that. So what I'll do is I'll say, I'll put, what if I try 2? So 2 minus 1, alright? That will be 1, right? That will be negative 1 to the power what? To the power 1, which is just negative 1. So the negative what will come at this point, you see? So that's how it will be what? It will be changing. So I've now managed to trace the negative. So that's good. So now I'll say nth derivative is equal to, that negative will be changing to of that function as what? N minus 1. Alright. So what about the number which was changing? This number here. Alright. This number here, how was it changing? So that's the coefficient now. Alright, so the coefficient was changing as what? This one was changing as, so when it was changing down there, alright, so it could give us what? So there was one thing, the number which is coefficient and also the denominator was changing. So what about the number which was coefficient here? So 1. So the first derivative, it gave us what? 1 there. The second again gave us 1. The third gave us what? 3. So how will be that changing? Alright, so that's where we come in to say when we have, so it started with the there, that's where it started changing. Alright, So it started from 1 to what? To 1 to what? To 3. Then from 3 there it gave us what? 15. So how can we trace this 15? Alright, so this is now the work that we have to do. So we need to trace this 15. After tracing the 15, that's when we'll be what? Will be done. So we'll trace 15 as the how it was changing. Alright, so we can say when n was the, so we only got n when n was what? 3. Alright, so we'll be lighting n to the power n. If I light n to the power n, alright, then I'll have what? The same thing. So if I light 1 to the power n there, then to give me 1 like that. If I light n to the power n again, first derivative, it will give me 1. If I light n to the power 2, it will give me 1 again. Alright, but if I light n to the power 3, I mean n to the power 3, so this n, it will be to the power of the same kind. Alright, so this is the first, second, and what? Third gave us 3, alright, which is there. Then fourth gave us like that. So what we are going to do is we'll say n minus what? N minus 1 like that. So if I light n minus 1, that will be now 2. 2 to that power n to the power 2, that will give me 4. So we don't have that. So this has failed. So in short, you have to look at the thing that you need to have. So that's where now we'll give you the patterns. So in one of the patterns, so now pay attention. I want to give you patterns and see which one will hold this. Alright, so can we go? So the patterns that I'll give you now, we'll come back to this. Let's go to the patterns. Okay, so that's simple. We'll come back to it after we get the pattern. So suppose so you just have to, when you see that, let's say it's giving you challenges, you do this blah blah blah, blah, you work out this blah 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 blah, blah, then you come now to the pattern. Okay, so the patterns will be like, so if we have the n factorial, let's say we are given y is equal to 1 over something, a linear like we had the one for x, plus b, let's say a plus b like that. So this n factorial of this, you write what? -1 open bracket to the power n like that. Then this change in n factorial, the same n, then a to the power change n like that. Okay, hope that is clear. So that is likely to be the answer for that one you had. So in short, that's the answer. Okay, so that's the n you'll be using. So that's the form you'll be using. So from there then, so this is the form you'll be using, provided you put 2 as the constant. Alright, so you put 2 as the constant. So now what you're going to do is we'll write the factorial like that. So we'll write the same ax, okay, plus b can be 0, so so just know that you have b when I give you, let's say x, you have b there, which is 0. Okay, then from there then you write n plus 1. So that's a change. So that's scenario 1. So scenario 2 will say the nth derivative of, let's say 1, y is equals to open bracket of such kind. Alright, so of such kind we have, let's say ax, alright, then plus b, okay, to the power what? B like that. Okay, okay, so this is the form now that we had, you see. So this is the form that we had. So this is where you answer that question. So now what you are going to do is, when you have such a form, alright, so when you have such a form, alright, so when you have such a form, what you are going to do is we'll say the nth factorial of that thing, you say, so that is the one I left now. Get it clear? So you say, you bring the formula to say -1 will be traced by that pattern, alright, then we'll write n plus 1, alright, plus 1 like that, then factorial, alright. Then after writing factorial, you bring that constant a, then you write to the power what, n. Then but down there what will be changing is the same change with now 2. So I'll say x plus what, plus b. Then the change now for that case, because it is of such kind, let's say you have the number 2 there. So let me write this. Okay, so then this is the kind I'm talking about, a quadratic one, the one with the over. So you write plus 2, the one you found there. Remember for the other one we had what, we are just changing what, the first one, this one we are just changing because there was 1 there, and that's the one I put there, alright, and there's nothing changed much. Okay, so you can master these things. Okay, so suppose you are given now of the type to the power, let's say natural log of ax, like that. So this, you see that what will be changing will be just a certain number, which the constant, this constant will be changing. So we'll say n to the power, a to the power n, then you write the same thing. Alright, so that's how it will be changing. So you'll give them the nth pattern as this one. Alright, so again, so if I give you again of this type, let's say a natural log, though you don't normally do my natural log, but I can show you to say you do this after you differentiate the natural logs, then you have something like, so let's say you have given natural log of, logs of what, ax plus what, b, of course. Then what are you going to have as the nth derivative? So the n pattern of the negative will remain the same, provided here is minus, then open bracket, here is n minus what, 1. Then natural, we write the factorial like that. Then we write a to the power n, open bracket, alright, you write it down there as the same thing, ax plus b, open bracket. For this one you maintain the same one you have. So the other one that we can have is, suppose you are given suppose you are given to say y is equals to sine, alright, sine something, alright, so sine linear, alright, it can be sine 2x because now the b will be 0 there. So the nth derivative of that kind, you can master these guys. So the nth derivative of that, you can say a the power n like that, then sin, you write like that, then open bracket, okay, then you write n pi, then over what, 2 plus a x plus what, b, like that. Okay, so you know the b, you know the a there, the value of it. So b can be 0, if anything like that. So that's how you'll be writing that. Okay, so very simple, right? So before that, I can give you a question. So I think I saw a question on that one. So this one, from sine, so y is equals to sine 2x. Let me do it. So suppose you are told to say y is equals to what, sine 2x. So here this is y is equals to sine, open bracket, 2x plus what, 0. Okay, so here how you be writing the pattern will be, say nth derivative is equal to, you write that the a now is 2, so you say 2 to the power n, alright, then sine, open bracket, the n now is what, the same n, you write n over, alright, 2, then pi, like that, then plus your ax is now what, a is what, is 2x, then the b is what, is 0, like that. So you are done. This is how you'll be writing it. So you say y to the power n, nth derivative of that kind, sine something, sine linear angle, so it will be what, n to the power n, then sine what, so n over 2 pi. Okay, that's how it will be changing, plus 2x, like that. So that's how it will be changing. So hope that is clear. So you should solve for cos, try for cos and also compute. So just try to actually as if you are doing some changes. You try to keep on as if you are tracing the pattern, then give the answer at the end. Okay, we'll do more in the past papers of such type. So in the past papers we'll be doing more. Alright, so that is it. So suppose now you are given this kind. Now for cos, y is equals to cos ax plus what, b, just like that case again. Alright, so here what you do is you write n to the power n like that. Okay, then cos, open bracket, then you write the same thing here, pi over 2. Alright, after writing pi over 2 there, you just write the same thing. Alright, so for cos and you can master this. It's about mastering, guys. So you master this type. So suppose you have this again. So you say y is equals to what? So then what you are going to do is, we'll say, suppose we are given this format now to say of the product type. Now you're given with a what, let's say ax, then sin something. Okay, so sin the same thing we have been talking about. So sin ax plus b, a linear, then what will be the product? Okay, so let me just lab this so that I create more space. So this is question 7. I'll say if you are given y is equal to e to the power, let's say ax, alright, then sine of the same stuff linear ax plus b. So the answer for this one, the nth derivative that you should derive at the end, should look like this. You write a squared plus b squared. Alright, after doing this, you say, you write now that thing to the power n over 2, then times, okay, times, then e to the power the same thing. Alright, then now you come now to the angle, you say sine, open bracket, then bx, alright, plus c. Okay, so c is that constant, then then you write plus again, alright, n tan what, tan inverse of b over a, like that. Okay, so it's negative b, I mean it's b over a, the inverse, tan inverse of b over a, something like that. So get what I said. Alright, so it happens the same case when you have cos, you do the same when you have cos. So that is it. So even when you have cos, it's still the same. Sin ax plus what, plus b, like that. So it is still the same thing. Alright, so that is it. Suppose now you are given for this one, let me test you this kind. Alright, suppose now you have let's say y is equals to exponential of let's say 6x, like that. So how will be the pattern changing? Alright, well, you start just blabbering to say, okay, that will be now 6 e to the power what, 6x. Then here, or the second one, it will be what, 6 times 6, alright, times e to the power what, 6x. Again, the third one, it will be 6 prime. It will be what? 6 times 6 times 6, then times e to the power what? 6x, like that. So again, you say the fourth one, it will be what? The fourth one to be 6 times 6 times 6 times 6, then times e to the power 6x, like that. So you can see something is changing here. Only what 6 is changing as what you increase the number of n. So what you are going to do is, I'll write y nth derivative of this. It will be what? That 6, which is a, okay, it was changing by what? By n. Then I write the same thing, I maintain like that, meaning that the nth derivative of this one was what? N is equals to, our a is what? 6 to the power n, then to the power what? Ax, like that. So let me say I want to find the second derivative, or this one is 36, right? Give me 36, then e to the power what? 6x, like that. So I want to try that. If I put to the power what? N, I put to the second derivative, so I'll say n is now 2, alright? So which is just the same thing, which is 36, then e to the power 6. So it's still the same. So you maintain this one, we got it from here, alright? So that's how you do it. So we'll solve a lot of questions in the tutorial sheets, I mean in the past papers. So we'll meet in the such expression. I know you can't get it clear, but it will make sense on that day. Thank you very much for watching the video. See you in the next video. And please subscribe, like, and also you can inbox on the line 09700200920 to access more solved tutorial sheets and papers for Bank 2 and other type of engineering mathematics. Thank you. Bye.